Good afternoon, this is Mr. Morales, and today I'm going to be discussing the setup and preparation for graphing cubic functions. This is day 2's assignment for the third 9 weeks. Now, I'm going to go over 3 examples for you, and I'm going to recommend either using your back of your worksheet or a separate sheet of blank paper to do basically the grunt work. So the way it's going to work is what you're going to do is you're going to take each one of these equations for each one of these graphs on each grid, and you're going to make a function table. So let me explain to you what I mean by that and begin with number 1. Number 1 says we have f of x equals x to the third power. So this is our parent function graph. F of x equals x to the third. What I'm going to do is get a sheet of paper and make a function table. But before I do that, I'm going to make some predictions. I know that the parent graph of f of x equals x to the third was a curved graph that went through the middle, went through the origin here. Now, I don't see any transformations. I don't see anything in parentheses being added or subtracted, shifting it left or right, anything being added or subtracted to the end of it to make it move up or down, and I don't see any numbers in front of the x to make it change direction or expand or shrink. So I'm going to assume that my vertex for this first one, my first graph, should be going through 0, 0. So there's my prediction of where the turning point or the vertex should be. So what I'm going to go ahead and do now is I'm going to go ahead and I'm going to make a function table. So I'm going to get a blank piece of paper. The function table is always 3 columns. So I'm going to go ahead and label this number 1. X, make 3 columns. Third column is y. And the function I'm using today is x to the third power. Now, I want you to have at least a minimum of 5 points to use. If all 5 fit, that would be great. But if they don't, then that is fine. Also, you'll graph the ones that do fit. Wherever you think the vertex is, I want you to make that your middle point. So I suspect my vertex is at 0, 0. So let's go ahead and first check that. If I plug in 0 for x, 0 to the third power, 0 times 0 times 0 does indeed equal 0. So that point does work. Since that's my vertex, I'm going to pick a point or 2 before the 0, like -1 and -2, and 2 numbers after the 0, +1 and +2. Each one of these will get a turn in the function table. So I'm going to take -2 to the third power, -1 to the third power, +1 to the third power, and 2 to the third power, and get all those results. So -2 to the third power, -2 times -2 is +4. +4 times -2 again gives me a -8. -1 to the third power is -1 times -1, which is +1, times -1 again, which gives me a -1. 1 to the third power is just 1 times 1 times 1, that's +1. And 2 to the third power is 2 times 2 times 2, which is 8. So here's my points. I'm going to go ahead now and take these points, I'm going to graph them back on my grid over here. So my first point is at -2, -8, 1, 2, 3, 4, 5, 6, 7, 8. The next point is at -1, -1. After that, it's at 0, 0, like I predicted my vertex should be. Then I have a point at 1, 1. And then my next point is at 2, 1, 2, 3, 4, 5, 6, 7, 8, right there. Now, I'm going to go ahead and just make my graph. Make sure you make it a curve at the vertex, and then I'll draw my arrow points. And there's my first example. Our vertex was indeed at 0, 0. The vertex is the point where your line changes direction, curves the other way. So it went from curving to the left side at 0, 0 to curving to the right side up. So wherever you predict your vertex to be, that is where the turn should happen in your graph if you did it correctly. Let's try another example. Number 2. Y equals x to the third minus 4. So here's the function. Now I see a translation. There's no parentheses, so that means I'm not going to move left or right. But I do have a -4. Whenever you're adding and subtracting a number after the x cubed without parentheses, that's going to cause a vertical change, up or down. -4 means that instead of my middle point being at 0, 0 like it was in the last problem, it's going to actually be moved 4 squares down. 1, 2, 3, 4 to right here. So I predict, based on just the equation alone, that my vertex should be at 0, -4. So I'm going to go ahead and verify that now. I'm going to make a function table for x to the third power minus 4. So I'll go back to the blank paper that I had, and I'll go ahead and make a new function table. I'll just use this one right here. So let's go ahead and start number 2. Number 2's function table began with x. The function is x to the third power minus 4. And then we want to get each y value. We need to have at least 5 points, with the middle point being where I suspect the vertex to be. I suspect it to be at 0, negative 4. Let's see if that point is at least mathematically a correct point. It was not at least the vertex. 0 to the third power means 0 times 0 times 0, which is 0. 0 minus 4 does equal negative 4, so that point does work. Since that's my base point, I'm going to use the two numbers that came before 0, which is negative 1 and negative 2, and the two numbers that come after 0, positive 1 and positive 2. Now, each one of these numbers will then take a turn in the function machine. And I'll do each step one at a time, or each, row one at a time, to get each y coordinate that I need for these x coordinates. So let's start from the top and work our way down. Negative 2 to the third power is going to be a negative 8. Negative 8 minus 4 more is negative 12. I can already tell that that point won't fit on my graph. Negative 1 to the third power is negative 1. Minus 4 more is negative 5. That point will fit. 1 to the third power is 1. 1 minus 4 is negative 3. 2 to the third power is 8. 8 minus 4 is 4. So these points mostly should all fit, except for maybe the very first one, which is a little too big. So going back to my grid, I'll go ahead and graph the points I do have. So I know at negative 2, 12, that's too big. If I really wanted to get it on there, I know 10, 11, 12 would be about right here. So I'll just put the point there anyways. Negative 1, negative 5 means back 1, down 1, 2, 3, 4, 5. I know I had 0, negative 4. That should be the vertex, and it looks like it's going to be the vertex. 1, negative 3 is my fourth point, and my final point is at 2, positive 1, 2, 3, 4. So here's my graph. It shifted down 4 units from the origin, just like I predicted. Cool. So these first two examples that I did for you, numbers 1 and number 2, had vertexes that were either at the origin or just a square or two away from the origin. Now let's practice one of the more complicated ones you're going to see, and we'll do that with number 5. So number 5 says y equals x plus 2 to the third power plus 2. So I can already identify at least two transformations. The plus 2 inside makes a move left or right, and the plus 2 outside is going to make a move up or down. So if I begin at the origin and look at my rules from yesterday, the plus 2 means I'm going to go 2 squares to the left. So the origin, instead of being at the 0, 0, will now be 2 squares to the left. The plus 2 outside means the origin is going to raise 2 squares up. 1, 2. So right here is where I suspect my new vertex to be. And the vertex is at negative 2, positive 2. So we'll go to our blank piece of paper and make our next function table to see if we indeed do get that. So it's x plus 2 to the third power plus 2. So back to my blank paper, I'm going to go ahead and make another function table. This is for column number 5. We have x's. Our function is x plus 2 to the third power plus 2. Use some space here to show my work. And I have y. I need to have at least 5 data points on my table. And I suspected that my vertex was going to be at negative 2, positive 2. So we'll begin with that point first. I'm going to plug in the negative 2 into my function and see if I get a positive 2. Negative 2 plus positive 2 is 0. 0 to the third power is still 0. 0 plus 2 is 2. So that point is a good point. I'll pick the two numbers that came before it, negative 3 and negative 4, and the two numbers that come after it, negative 1 and 0. Each one of these numbers will take a turn in the function machine, or in other words, your calculator. Oops, negative 3, plus 2 to the third power, negative 1 plus 2 to the third power, plus 2 at the end, and 0 plus 2 to the third power, plus 2. So let's get each one of these values. one at a time. Negative 4 plus 2 is negative 2. Negative 2 to the third power is negative 8. Negative 8 plus a positive 2 is a negative 6. Negative 3 plus positive 2 is a negative 1. Negative 1 to the third power is still negative 1. Negative 1 plus 2 gives you a positive 1. I already did the third point, so I'll go to the fourth point. Negative 1 plus 2 is a positive 1. Positive 1 to the third power is 1, and 1 plus 2 gives me a 3. And finally, 0 plus 2 is 2. 2 to the third power is 8. 8 plus 2 is 10. So these points should all fit on my graph. So let's go ahead and check it out. So let's begin. We have negative 4, negative 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, negative 6. There's the first point for my table. Negative 3, 1, 2, 3, positive 1, right here. I already have the negative 2, positive 2 as my vertex or my turning point. Negative 1, positive 1, 2, 3, right here. And then I have 0, positive 10 up here. So my graph's going to snake up from here, curve, and then go up like that. All right, so the rest of these graphs are going to be yours to do. What I want you to do for all of these is to first, using our rules for interpreting transformations, tell me where you suspect the vertex or the turning point will be. That's the point at which the graph switches from one direction to another, or from the left side to the right side, in other words. Give me that for all of these, and that vertex that you predict will be your middle point in your tables when you set them up, like I did here, or like when I had my vertex here at 0, negative 4, or the last one I had here. That's your middle point on your table, and you'll pick two numbers that come before that x value and two numbers that come after. And do the math, and you should be able to successfully graph all of these graphs, all of these graphs onto your assignment. All right? So best of luck, and make sure to ask any questions if you have any concerns. All right, thank you very much, and have a great day.